Hello everyone, in this video we're going to go over the relationship between lines that are parallel and lines that are perpendicular. So just a quick review, parallel lines are lines that are going in the same direction and never intersect. And perpendicular lines are lines that intersect and create a 90-degree angle. And in order to find the relationship between these types of lines, we first need to compare their slopes. So before we get started, what is slope? So we know that slope is a change in y over the change in x. And the way we see that on the graph is, if I want to find a change in y, I need to look at the y-axis and compare how the graph is shifting up and down. And so usually that's why the change in y is going to be called the rise. And to find the change in x, I need to compare how the graph is shifting side to side. And that's why usually the change in x is called the run. And so by comparing the slopes, I'm able to find a relationship between lines that are parallel and lines that are perpendicular. Let's go over our first example problem involving parallel lines. So here I have a set of parallel lines, lines A and B, and I want to find the relationship between their slopes. So first let's find the slope of line A. So to find the slope, I need to find the rise and the run. So from one dot to the next, I know that I'm rising up one space, and I'm shifting to the right 3 spaces. So to write my slope is going to be rise over 1, so I have 1 over 3. All right, now let's find the slope of line B. I need to find the change in y, so how much I'm shifting up, which is plus 1. And to get to the next dot, my change in x is going to be plus 3. So the slope of this line is going to be 1, 3. So what do we notice? When we have two lines that are parallel, they're going to have exactly the same slope. And that kind of makes sense, right? In order for lines to be parallel, in order for them to never intersect, they have to be moving at the exact same rate. So in order for lines A and B to be parallel, they have to have the exact same slope. Let's go over example problem 2. Here I have line A and B, and these are perpendicular lines. They're going to intersect, and when they intersect, they create this 90-degree angle. And so I want to find the relationship between their slopes. So let's start off by finding the slope of line A. So first, I need to find the change in y. To get from one dot to the next, I see that I'm moving down 5 spaces, so my change in y is going to be negative 5. And I'm moving to the side 2 spaces, so that the change in x is going to be plus 2. So to write the slope is going to be negative 5 over 2. Now let's find the slope of line B. To get from one point to the next, I need to find my change in y. So I know that I'm shifting up plus 2. And then to find my change in x, I'm shifting to the side plus 5. So the slope of line B is going to be 2 over 5. So how are these slopes related? They kind of look similar, right? They're both using the same numbers. They both use 2 and 5, but how are they different? So I noticed that from slope A to slope B, the fraction is going to be flipped. Here I have 2 on top, 5 on the bottom, and over here I have 5 on top and 2 on the bottom. So notice that my slope is being inverted, it's being flipped. And what else I noticed is that the slope is going to have an opposite sign. This slope down here is going to be positive, and the slope up here has a negative. So in order to get a line that intersects and create a 90-degree angle, I need to flip my fraction and give it an opposite sign. So if that's how my two slopes are related, let's go over our third practice problem involving parallel lines. So here I want to write a parallel line that's parallel to line B. So first I need to find the equation for line B. I know that the template for a linear equation looks like this. Y equals mx plus b, where m is going to be my slope and b is going to be my starting point, or my y-intercept. And so to find the equation for line B, first I need to find the slope. From one dot to the next, I know I'm going up 2, so my change in y is 2, and I know I'm moving to the side 3. So the slope of line B is going to be 2 over 3. And now I need to find my y-intercept, or my starting point. And I see that the graph crosses the y-intersect at negative 2. So my starting point is going to be at negative 2. So this is my equation. In order to find a line that's parallel to B, I want a line that has the exact same slope. So if line B has a slope 2/3, then I know that line A has to have a slope of 2/3 as well. So y equals 2/3. And for my starting point, it doesn't really matter what my starting point is. So just for this example, I'm going to leave my starting point as positive 2. Okay? So if I graph the point 2/3 x plus 2, I know that that line's going to be parallel. Let's go ahead and check that out. So I know that my starting point's at 2. And to get from one dot to the next, I need to rise up 2 and move to the side 3. And so if I connect a line connecting these 2 points, this blue line is going to be parallel to that red line. All right? So that's how I find a line that's parallel to each other. Right? Example problem 4. I want to find a line that's perpendicular to line A. So here I have line A, and I know that the template for a linear equation is y equals mx plus b. And so I want to find the slope, and I want to find the starting point of this line here. So I know that the rise is going to be, I'm moving up 3 spaces, and the run is going to be, I'm moving to the side 4. So the slope of line A is going to be 3/4. Right? And I see that the starting point of line A is going to be right here. The graph crosses the intersect at positive 3. So in order to write an equation that's perpendicular to line A, I need to take that fraction, flip it, and then give it an opposite sign. So if I know that line A has a slope of 3/4, in order to get a perpendicular line, the perpendicular slope has to be, first it's flipped, so 4/3, and then it has to have an opposite sign, negative. Again, the starting point doesn't really matter that much as long as the slope is flipped and opposite. So let's start this one off at, let's say, -1. So let's graph this line and see if we create a line that intersects at a 90-degree angle. So starting at -1, to get to my next dot, I know that I need to go down 4 spaces and then to the side 3. So go down 4, to the side 3. And when I draw a line that intersects these 2 dots, my red and blue line are going to intersect and create a 90-degree angle. Right? For our 5th practice problem, I want to find the slope of a line that's parallel to line A. So if I know that line A has a slope of 7/12, how do I find a line that's parallel to line A? So I know that for parallel lines, the slopes have to be exactly the same. So for line B, the slope has to be 7/12. And then finally, for our last practice problem, find the slope of a line that's perpendicular to line A. So if I know that line A has a slope of 5/8, what would be a slope that's perpendicular to that? So the first thing I need to do is I need to flip the fraction. So it's going to be 8/5. And then I need to give it an opposite sign. So instead of being positive, it's going to be negative. And if I use that slope, those 2 lines are going to intersect and create a 90-degree angle. So in conclusion, the relationship between parallel lines is that both the slopes have to be exactly the same. And when I have perpendicular lines, the slopes have to be flipped and have an opposite sign.